Good morning, everyone. Welcome to Guru Brahma classes for JEE and NEET. Today's topic is Heisenberg uncertainty principle from the chapter Atomic Structure, and in that we are discussing about PYQ of JEE Main. PYQ means previous year's questions. So Heisenberg uncertainty principle. What did we learn in Heisenberg uncertainty principle? A video was already made on this principle. In that, very detailed explanation is discussed. So what is Heisenberg uncertainty principle? It is impossible to find the exact position and exact momentum of an electron simultaneously. So to represent that Heisenberg uncertainty principle, it is mathematically represented as delta x into delta p is greater than or equal to h by 4 pi. So what is delta x here? Uncertainty in position of electron, where delta p is equal to uncertainty in momentum of electron. So here delta p, we know that p is equal to m into v. So delta mv, this can be written as m into delta v plus v into delta m. As the mass of the electron is constant, we can write delta m is equal to 0. If delta m is equal to 0, delta p will be equal to m into delta v plus 0. So delta p can also be written as here m into delta v. Okay. Then what is delta v? Delta v is equal to uncertainty in velocity of electron. Uncertainty in velocity of electron. So this is what he has given. Uncertainty principle is mathematically represented as delta x into delta p is greater than or equal to h by 4 pi. Let us use this formula and solve the questions. So here in 2021, what is the question asked? A ball weighing 10 grams. So mass of the ball is given as 10 grams, and other quantities like velocity 90 meter per second. The answer is asked in meters, and the Planck's constant is also given in SI unit. So let us convert it into SI unit. Then that is equal to, when gram is converted into kg, we need to multiply it with 10 power minus 3. 10 power minus 3 kg. So then what do you get? 10 into 10 power minus 3 is 10 power minus 2 kg. Right? So mass is given. And velocity is also given. Velocity of the ball. What is that? Velocity of the ball. So velocity of the ball is given as 90 meters per second. So we are applying this uncertainty principle for a ball. This ball is moving. Right? And he said that if the uncertainty in its velocity is 5%, that means delta v is equal to 5% of its velocity. 5% of its velocity. So what do you write? 5% means 5 by 100 into its velocity is already given as 90 meters per second. That is equal to 9 5 is 45. 45 by 10 gives you 4.5 meters per second. Okay. So what did we get? We got delta v. Then what is asked? Delta x is asked. Then the uncertainty in position is dash into 10 power minus 33 meters. So what is delta x? You know that delta x into m into delta v is equal to or greater than h by 4 pi. Then delta x is equal to h by 4 pi into m into delta v. So h is already given in the question, and that is 6.63 into 10 power minus 34 joule into second, okay, by 4 pi. 4 pi means calculate 4 into 3.14 into mass of the ball. We are calculating for a ball. What is mass of ball? 10 power minus 2 kg into velocity. Uncertainty in velocity, we have calculated it as 4.5 meters per second. So then what do you get? On calculating this, we get it as 1.17 into 10 power minus 33 meters. So approximately 1 into 10 power minus 33 meters. So in the question it is asked dash into 10 power minus 33 meters. So answer will be 1. It is that type of question. So it is that type of question. So let us see the next one. Here an accelerated electron has a speed of, so what is given? Speed is given, speed or velocity, right? So we can take it as velocity is equal to 5 into 10 power 6 meters per second. Here its uncertainty is given. How much percentage? 0.02 percentage. So delta V is equal to 0.02 percentage of its velocity. Okay. So that is equal to 0.02 percentage means by 100. Okay. Into what is its velocity? Its velocity is given as 5 into 10 power 6 meters per second. Then how much you get? So 0.02 can be written as 2 into 10 power minus 2 divided by 100 means 10 power minus 2 again into 5 into 10 power 6 meters per second. So then that is equal to 2 5 is 10, 10 into 10 power minus 4 into 10 power 6. That is equal to 10 into 10 power 2, that is equal to 10 power 3 meters per second. So we have delta V. We have delta V. Then uncertainty in finding its location while in motion is x into 10 power minus 9. X into 10 power minus 9. So we need to calculate delta x. Again, similar type of question. So delta x into m into delta v is greater than or equal to h by 4 pi. So delta x is equal to h by 4 pi m into delta v, that is equal to h given already 6.63 into 10 power minus 34 joule into second by 4 into 3.14 into here you can see here mass of the electron is given. That value you need to write 9.1 into 10 power minus 31 kg into delta V. Delta V we have calculated it as 10 power 3 meters per second. Right? So what is asked here? x into 10 power minus 9. The question asked is uncertainty in finding its location. So uncertainty location means position, delta x. So then what do you get? 6.63 by 4 into 3.14 into 9.1 into 10 power minus 34 plus 31 minus 3. So then what do you get? 4 3 is 12, 12 9s 108. Here how much you are getting? 10 power 34 3 37, 37 31. So minus 6. So 6.63 by 4 into 3.14 into 9.1. So if you calculate this, so let us take what you get is 58 into 10 power minus 9 meter. So the answer will be 58. Right? If you calculate it, you will get it as 58. Understood? So what did we do first? We have calculated delta V. Then we have substituted the remaining things what are given in the question, right? Let us go with the next question. So asked recently in 2024, based on Heisenberg uncertainty principle, that uncertainty in velocity of an electron to be found within an atomic radius of diameter 10 power minus 15 is. So from this what is asked? Delta V is asked. Delta X is given 10 power minus 15 meters. Okay. 10 power minus 15 meters. So then let us take the same delta V. Now delta V is asked. We have formula delta X into M into delta V is equal to or greater than or equal to H by 4 pi, right? So what is asked? Delta V. Delta V is equal to greater than or equal to H by 4 pi into delta X into M. That is equal to 6.626 into 10 power minus 34 joule into second by 4 into 3.14 into delta X is given as 10 power minus 15 meters into mass of the electron. Mass of the electron is 9.1 into 10 power minus 31 kg. So delta V, what do you get? So we get it as 58 into 10 power minus 9 meters per second. So what is the question asked? This is minus, right? So what will be the answer? 58. Let us see next question. If the uncertainty in velocity and position of a minute particle in space, a particular particle is given, this particle uncertainty delta V is given as 2.4 into 10 power minus 26 meters per second, and delta x is also given. How much position of a minute particle is given 10 power minus 7 meters. Then mass of that particle in grams is, you know that delta x into m into delta v is greater than or equal to h by 4 pi, right? Then m can be written, m can be equal to or greater than h by 4 pi, okay, delta x into delta v, that is equal to h by h already given. How much h given? 6.626 into 10 power minus 34 joule into second by 4 into 3.14 into delta x is given as 10 power minus 7. Okay, delta v given as 2.4 into 10 power minus 26 meter per second. So on calculating this, what do we get? Okay, 22 into 10 power minus 3 kg we get. Okay, that is equal to, but the question asked is in grams. So 22 into 10 power minus 3 kilo means 10 power 3 grams, right? Then what is the answer? 22 grams. So the answer will be 22. Okay, let us see next question. So this question, recently it is asked 2025. The recent examination it is asked. What is that question? Let us see that. Statements, two statements are given, statement 1 and statement 2. So what are those two statements? It is impossible to specify the simultaneously with accurate arbitrary precision, with more precision, more accuracy. Arbitrary precision means with more accuracy, both linear momentum and the position of the particle. That is what the Heisenberg uncertainty principle is. What is his statement? He stated that it is impossible to specify simultaneously. At the same time, it is impossible to calculate accurately, more accurately. Arbitrary precision means more accurately, both linear momentum and the position of the particle. So that is what the Heisenberg uncertainty principle is. So statement 1 is correct. So let us come to statement 2. If the uncertainty in the measurement of position and uncertainty in measurement of momentum are equal, what he says, delta x is equal to delta p for an electron, then uncertainty in the measurement of velocity, then what is delta v, he is asking. Okay, so we know the formula, delta x into delta p greater than or equal to h by 4 pi. These two are equal, then I can write it as delta p square greater than or equal to h by 4 pi. So delta p can be written as m into delta v square greater than or equal to h by 4 pi. So m square and delta v square greater than or equal to h by 4 pi, and delta v square greater than or equal to h by 4 pi into 1 by m square. Then delta v is greater than or equal to root h by 4 pi into 1 by m square, that is equal to root h by pi, root 4 is equal to 2, root m square is equal to m. So delta V is greater than or equal to root h by pi into 1 by 2m. So root h by pi into 1 by 2m. So this statement is also correct. So what will be the answer? Both statement 1 and statement 2 are true. Understood? So that is all with the PYQ from the Heisenberg uncertainty principle. Let us meet in the next video with another topic. Right? Thank you.